So, welcome to all of you. Today we will learn the implementation of another classification technique, that is a decision tree, by using a Python programming.
Now let us discuss about the decision tree. So let us understand this concept by taking one example. Suppose we want to play cricket today. Now we should first consider the weather condition that may or may not permit us to play cricket. For example, if it is raining today, we may not be able to play cricket. And if temperature is too high, then we may not play cricket. But if it is a overcast day where cloud can be seen and weather is cool, we may play cricket. In the same manner, our decision of playing or not playing cricket will be affected depending on the weather conditions. So what we are doing here, we are taking a final decision depending on a certain conditions or rules. This is what decision tree does. Now a decision tree in a machine learning model that gives the decision after considering certain conditions, it may basically partitions the data based on the condition to arrive at a correct decision. Now the decision tree, it is look like a tree structure as it is showing over here. Now we are showing basically one of the decision tree that represent the data that help to take a decision whether to play cricket or not under the given weather condition. In this decision tree, the topmost node, this node, is called as a root node. For example, Outlook. Outlook is the root node over here that represent the outlook of the day. This node may have a value like value called attribute, right? These are the attribute. For example, this outlook may be sunny, it may be the overcast, or it may be the rainy, which are called the attribute. This attribute can be imagine like the branch of the tree. Below this root node, we can have another node. For example, windy is the another node. This node may have a value called again the attributes. For example, here this windy may be true or false. That means there may be wind or not that day. This means true or false value become the attribute of this node. In this manner, there may be several nodes descending from the each other. Each node may have their attributes. Finally, there would be a decision in form of this yes or no. These are called basically the leaf node. For example, if it is a windy day, we may not be able to play cricket, right? So the final decision is represented as a no. If it is not a windy day, then we may play cricket. So here, this yes or no decision can be made finally, and they will become the last node in this decision tree. This last node, as we have discussed, they are called as a leaf node. So decision tree should arrive at a final decision after checking the several conditions. For example, if outlook is sunny, then it will check if windy is true or not. Then it gives the output. If it is a true, it will give you the output as a no. If outlook is sunny and windy is false, then it gives the output as a yes. Similarly, if outlook is overcast, then it will check if windy is true or false. Depending on this test, it will provide the output in form of yes or no. So this checking path actually is looking like a branch of a tree, right? So if we will observe this tree while drawing the conditions, drawing this decision tree, why we represent this outlook as a root node? That is a big question. So if we will observe the data, we can understand that there are other columns as well. So this is actually data corresponding to that we are having this decision tree. So if you see this data, we can observe that we are having another column like a temperature, humidity, wind as well. So why we have make this outlook as a root node? So that thing we have to understand now. So concern is which column should be taken as a root node. So basically it depends on the entropy or Gini index. So basically if you discuss about the entropy basically represents the randomness of the data. So when entropy is more, the randomness will be more. That means data points are distributed here and there, right? It also indicates basically the impurity in the data, which keeps the data point apart from each other. Now if you talk about the Gini index, so basically this Gini index is a measurement of impurity in the data. There may be abnormal values or there may be values which provide the confusion in taking a decision. So basically this entropy and Gini index represent the impurity in data only, whereas entropy indirectly represent the level of impurity in the data, whereas Gini index directly measure the impurity in the data, right? So here is a data point where we are having a high entropy. This is a data point where we are having a low entropy. Now let us discuss about the entropy, how to calculate the entropy and how to find out the information gain out of it. So basically when entropy value is low, the data contain basically the less impurities. When impurities are less, it provide more useful information to the decision tree algorithm. So this is called the information gain. This is the reason entropy is generally applied to each node in the decision tree to calculate information gain, right? So when the information gain is the highest for a node, it should be taken as a root node. Now below the root node, we will represent that node which has a bit less information gain. So in this manner, entropy helps us to decide the root node and subsequently the other node that are represented in a the subsequent label. So the formula to calculate the entropy is this: ES is equal to minus PS log base 2 PS minus P no log base 2 P no, where this ES represent the entropy of the sample space and this PS represent the probability of yes and P no represent the probability of no. So the sample space S indicate the all data points, right? So that is the idea how this entropy we calculate. Similarly, let me show you, because this is our data. So this is our given data. Now we must understand how this entropy we have calculated, because here in this table I have given you the output, right? So this is basically information gain for the outlook node, and similarly we have calculated the information corresponding to the other features like a temperature, humidity and windy, right? So here basically if you see this table, the highest information gain value, that is a 0.247, is seen in this outlook. Hence this column should be selected as a root node. The next highest value is seen with respect to humidity, right? Hence this column becomes the node at the next level. In this manner, this entropy is basically used by the decision tree algorithm to decide which column should be used as a node at a different level. Now concern come how to calculate it. So hopefully we have learned it. Only for the quick revision, I am showing you how this value actually we used to get from the formula by using the formula. So basically Entropy, as we have seen, is calculated by using this formula. So here S is the total sample space, PS is the probability of yes. Now there are two situations. If number of yes is equal to number of no, in that case probability of the sample space would be 0.5. Now if it contain all yes or all no, in that case the probability of S will become a 1 or 0, right? Now with this assumption, let us move and discuss this data. So this was our data, right? This was our data which we are having with us. So over the same data I am showing you this calculation. So this is the data which I have kept over here. So the concern was out of this outlook, temperature, humidity and wind, which node will become the root node. So as we have learned, we have to find out the information gain corresponding to each feature. Now the feature which is having a high information gain, that will become a root, and subsequently the other higher value of information gain corresponding to the each individual feature will prevail them to be the next subsequent the node, right? So with this idea I have calculated the information gain. So let us take first the outlook attribute. Now see in outlook attribute we are having different values like a sunny, overcast and rain. You may see over here in this column we are having this three value. Now corresponding to this column, now we have to find out the information gain. So firstly we are finding out the entropy of the sample. So in entropy of sample, if you will see, there are totally 14 column we are having, in which 9 yes we are having, 1 2 3 4 5 6 7 8 9. So out of this 14, 9 yes output we are getting, and we are having a 5 no. So that we are yes we are representing by plus, and minus is indicating the no. So that is for this entire sample space. So the entropy of sample will be minus 9 by 14 log base to 9 by 14, and 5 no is there out of 14, so it will become minus 5 by 14 log base to 5 by 14. So if you will solve it, then entropy of sample will be 0.94. okay. Now see, in this that was a total sample space. Now we have to see corresponding to each value. So in this outlook we are having a 3 value like a sunny, overcast and rain. Now corresponding to each value we have to find out the entropy. Now if it is a sunny, see here we are having a total 5 sunny, 1 2 3 4 and 5. Out of this 5 sunny, 2 times match we are able to play, and 3 times there is a chance we are unable to play the match. If you see this, 2 times no we are having, and here again there is a no, so 3 times no we are getting, and remaining 2 sunny we are able to play the match. So this 2 plus and 3 minus means 2 times we are able to play match, and 3 times we are unable to play match. So again based on this information, again we have to calculate the entropy. So again by using the same formula, we can open it, we can substitute the value in that formula, and we can see the entropy of S sunny will be 0.971. Similarly, we have to go with the overcast. In overcast, total we are having 4 overcast value in this outlook column, 1, 2, 3 and 4. If you see, whenever there is overcast, in all the situation we are able to play the match, right? And there is no chance of playing no cricket. So that's why the 4 yes we are having and 0 no. So if any values of this one will become 0, so entire entropy will become a 0 like that way, right? So that we have seen. Similarly, for the rain situation, so we are having a 3, 4, 5 times rain values are there in this outlook column. So in this rain situation, 3 times we are able to play the match and 2 times we are unable to play the match. So with this information, we have calculated the entropy. Now value is coming as 0.971. Now we have to find out the information gain. So we have to use this formula. So entropy of the entire sample space and the summation of these values, right? Entropy with respect to this values, we have to put it over here. Now I have substituted all the values over here, and this will return you the value as 0.2464, right? See here, SV by S is nothing but out of 5. See, 5 times sunny we are having out of this 14 data. So this value will be 5 by 14. Similarly, overcast, only 4 times overcast we are having out of this 14. So 4 by 14 would be there. Similarly, we are having a 5 by 14 because 5 times rains we are having altogether out of this 14. So 5 by 14 will be there. So if you substitute the value, so we will get the information gain corresponding to the outlook column, and the answer will be 0.2464. Similarly, we have to use the same formula and we have to check the information gain corresponding to temperature. Simply we have to substitute, so this value will remain same. If it is a hot, 2 times yes, 2 times no match we have played. If it is a mild, 4 times yes, 2 times no cricket was happened. Similarly, if it is a cool, 3 times yes, 1 time no we are having. Simply we have substituted the value over here, and if you simplify this, it will give you the gain, and gain value is 0.289, right? Similarly, we have checked with the corresponding to humidity. The same method we have applied over here. So if you solve this, again we may see here the gain value is coming as 0.1516. Again, S is the corresponding to the entire sample. In humidity we are having a 2 value. One is a high, another one is a normal. So in high, total 7 options we are having, in which 3 times match has happened, 4 times match was unable to be played. Similarly, normal, 6 times we have played the match, 1 time there was no chance to play the match. So by using this information, we have calculated this data, and here the information gain with respect to humidity is 0.1516. Similarly, we will go subsequently, we will check the corresponding to wind. So here also in wind there are 2 values, weak and strong. So again, out of 14, we have checked the sample in entropy. This value will remain same. Now for the strong, 3 yes, 3 times no. For the weak, 6 times yes and 2 times no we are having. Simply we have used the formula, open it as we have done earlier. And again here with respect to wind, the gain is 0.0478. Now let me put it all together so that you can understand this. So in the case of outlook, information is gain is this much. In case of temperature, this much value we are having for the information gain. In case of humidity, this much value we have obtained. In case of wind, this much value we have obtained. So this value only I have shown over here, right? So these are the value which I am showing over here. So this is how actually we can calculate the information gain. But this is not the end of this. Again, we may see here out of this 4, this value is high, and that is corresponding to the outlook. So one thing is very much clear now, that outlook will become the root, right? Now we have to find out which would be the subsequent node in the next level. So in outlook 3 attribute we are having like a sunny, overcast and rain. So now with the respect to sunny, there are this many rows will fall down, D1, D2, D8, D9 and D11. So we have to again do this analysis over here, and we have to find out which would be the next node. Similarly here in overcast, all the values are coming as yes, so this will become a leaf node. In rain, again this many rows are there, so we have to do the same analysis and we have to check which node will come over here. So let us move and check one more time. So you may see here in the case of sunny, there are 5 rows we are having, D1, D2, D8, D9 and D11. So this 5 row we have taken on. Now we have to find out. So next node should be temp or humidity or wind. So out of this 3, who will be the next node? That actually, that analysis we have to do with the help of this ID3 algorithm, or you may say by using this information gain. So again I did the same thing. This many rows I have picked from there. Now our task is to check that which node will be the next, which feature will become the next node. So again we have to perform the same analysis. Now this time we have to calculate the information gain corresponding to temperature. Subsequently you will check with the humidity and the wind, and out of this 3, the feature which is having a high information gain, that will become the next node. So I did the same analysis over here. Now this time the sample, in our sample total 5 values we are having, in which 2 yes and 3 no's we are having. So the information, entropy of this sample would be this value we have to substitute over here. This will be 0.97. Similarly, temperature. So there are 2 times. If the temperature is hot, then there is no chance of playing match, right? So 2 plus and 2, there was no chance of playing match, and 2 times we have played it, right? We could not play it 2 times. So this 2 minus is coming over here. So simply if any one of this is 0, means entropy will become a 0. In case of mild, 1 time match has happened, 1 times match has not happened. So that value we have substituted over here. We can check the entropy of mild is 1. Similarly with the cool, if the temperature is cool, yes, there was a chance where we can play the match. So 1 and 0, entropy will be 0. So if you solve it, the gain will be 0.570. Similarly, we have to check with the humidity and wind. So that we have a solve over here. In case of humidity, it is coming as 0.97. In case of wind, it is coming as 0.0192. Let me put it over here. So you may see here out of this 3, where we are getting the higher value. So you may see here we are getting a higher value in case of the humidity. So the next node will be the humidity, right? Again in humidity, we are having only 2 options, 3 high and 2 normal, right? So if this high is there, then there is no chance of playing match. So directly we are reaching to the leaf. If it is a normal, we are reaching as the yes, right? So there is a clearly, if it is a high, similarly there is no chance of playing match. If it is a normal, we can play the match. Now we have to take a call over here. We have to check which node will come over here. Same analysis we have to do. In the case of rain, this many rows are there, D4, D5, D6, D10 and D14. So again we have to follow the same method and we have to check the information gain corresponding to temperature, humidity and wind, and we have to check in which case we are getting a higher information gain, and that will be the next node. So same thing we have done with respect to temperature, same thing we have performed with respect to humidity and wind. So if I will summarize it, so this is the outcome, this is the information gain which we are getting over here. Now out of this 3, you may see highest information gain we are getting with respect to wind. It simply means here the next node would be the wind. Now see, in the wind there is only 2 options, either weak wind or a strong wind. So if the wind is strong, so there is no chance of playing match. In case of weak wind, yes option are there. So obviously this will become a leaf node. So this is the overall tree. Based on that we have to take the decision, right? So with this idea, we can come back over here. So this is how actually information gain will help us to build the decision tree. Similarly, the next concept which we can use for calculating the for forming the decision tree is with the help of Gini index. So Gini index is a direct measurement of impurity in the data. When Gini index value is high, impurity are high. When it is low, impurity is low. Hence, we should consider that column having a lowest Gini index as a root node. So the formula basically to calculate the Gini index is this much, right? So here this capital S contains the data point from the n class, and the Gini index of that data set is this one. So here this Pj is the relative probability of the class J in sample space. Now we will apply this formula and we can calculate the Gini index of each column in the data set. So this is the value which we are getting. So Gini index for the other column we are having this much, so that you can see over here. So among all the column, Gini index of outlook column, if you see, it is coming as a very low, that is 0.3429. That means there are very less impurity we are having. Hence we select the outlook as our root node, right? So the next node, next low value that can be seen for the humidity. So hence this column should be taken as the second level node, right? So that is the idea. Now see, we can compare this entropy and Gini index together. So both the entropy and Gini are basically used to compute which node should be taken as a root node in the tree and which node should be taken as a subsequent level. But if we compare both the method, then this Gini impurity is more efficient than the entropy in terms of computing power. So here we should remember that the term computing power, this indicate basically the processor time and you may say the memory. Now the entropy value basically will be in range of 0 to 1, whereas Gini values lies between 0 and 0.5, right? 0 to 0.5. The entropy values are increasing up to 1 and then it start decreasing. But in case of Gini, it goes up to 0.5 and then it start decreasing. Hence, Gini require less computational power. So that is a simple relationship which we can figure out with this plot. Now let us discuss about the how to implement it. So basically we have seen that decision tree in a machine learning model that contain a logic regarding how to split the data based on some condition and finally make the conclusion, right? So basically it internally create a tree structure with the column of the data set as a node in a various level. So the final nodes will provide yes or no type of decision or conclusion, or they will be treated as a leaf node. Now decision tree basically internally uses either entropy or you can use the concept of Gini index to decide the hierarchy of the nodes starting from the root node. Now let us apply this concept on this cricket data. Now see this data, let me show you this one. So this is our data. So this data set basically having a 14 rows and 5 column. Now column names are outlook, temperature, humidity and windy and play cricket. So the last column represent the target column, right? This one, and here we are having either no or yes. Now since this total data is in form of basically a string only, right? Or you may say the text. So we have to convert all this column into the numeric, right? So for this purpose we have to use the label encoder. So let me show you that one. So this is our data. So here total 14 entries we are having and totally 5 columns we are having. This is the integer type of that. Now as we have seen, this all data are kind of text or a string. Now we have to use the label encoder. So label encoder simply assign the value 0, 1, 2 to each category, right? For example, we apply label encoder to the outlook column. So the 3 attribute of outlook columns are converted as 0, overcast is 0, and if rainy is equal to 1 and sunny is equal to 2, right? Now thus label encoder will replace the overcast value as 0 and as I told you, rainy is equal to 1 and so on. Now see, thus these are the converted from text to numeric. Now label encoder can be created by creating an object called this label encoder class. So here we are calling this class and we are making an object of that. Now let us apply this label encoder on the column of the data set and create a new column with the numeric data using this fit transform method of the label encoder. So by doing this, you may see the last 5 column in the data frame represent the converted column that contain the numeric type of data only, right? These 5 columns, right? Now in this data frame, we can understand that column column data was decoded by the label encoder in this way, right? Overcast was 0, 1 was rainy, 2 was sunny, and the same thing is true with the other features, right? Now since all this 5 column has been converted into numeric, let us delete this column, right? Because this one we have converted in the numeric one. Now we will keep only this last column, and this last 5 column will contain the numeric data type. Remaining one we are deleting, right? So that one we have dropped. So that one we have dropped over here. X is equal to column means the entire column we are going to be dropped. After that we are let us divide the data into independent variable and dependent or target variable. So that one we have done over here. Now since this data is ready for the model, now we can apply decision tree classifier model on this data set. So let us create a decision tree by creating an object of decision tree classifier class, right? So that model we have done. Now we have trained the model. So here basically nothing we have given, right? So default criteria is Gini, right? That means the decision tree is created using the Gini index as a criteria in splitting the data. We can also specify the entropy as a criteria in the decision tree classifier that I did over here. So that one you can give as a parameter over here. So by default, it will take the criteria as a Gini only. Now we can also make the prediction using this model. Now my model has trained. Now we can perform the prediction. For example, we want to know if playing cricket is possible or not if weather conditions are given like this. So outlook is sunny, temperature is hot, humidity is normal, windy is false. So that value, the numerical value of that one is this much. So if you give this value to this model for doing the prediction, so the outcome of that is coming as 1. It simply means for the given condition, there is chance of playing cricket. Now, if you calculate the score of this model, so you may see the answer is coming as 1, right? So 100% accuracy, with the 100% accuracy, you can, this model will predict, right? So that is the idea how actually this model will work. Now see, you can change this criteria by changing the parameter into this decision tree classifier. So by default, as we have seen, it is a Gini index, but this value, the entropy you can pass as a criteria. Then by using the entropy concept, this model will be trained. So again, once you trained it, you can give the any value to this. This will give you the outcome corresponding to that, and we can also calculate the score of that. Similarly, we can plot our tree that we will see in upcoming exercise. How can we plot and how can we visualize the tree? So in upcoming lectures, we will discuss about it. Generally, it has been seen that decision tree is having a problem of overfitting. Now, this overfitting we can solve by using this k-fold cross validation technique, right? So from this decision tree classifier, you can from this sklearn model underscore selection, you can import this k-fold and cross val score. And here, this k-fold cross validation value we have given as 5. And if you will follow the steps, you can get rid of the problem of the overfitting. Now, let me show you one of the game which is actually using the concept of decision tree. So this Akinator, hopefully many of you have played. So this is basically using the concept of decision tree. Let me show you how actually it works. So let us start playing this. So actually it do the predictions, right? Based on the user input, it will tell you what would be the corresponding output. Basically, this entire game was designed with the concept of decision tree only. Let's say I want to predict about any actor. Let's say he's a Bollywood actor, and he's a old actor. For example, let's say Jackie Shroff or maybe Amitabh Bachchan, like that. So let us see how this game will help us to reach up to there. So let's say I want to, my input is a character which I want to know. Now these are some questions which we have to answer, and based on this input and based on the decision tree, it will help you to find out what would be the corresponding output. Now the next question is your character is Muslim? Let's say no. And does your character works in Bollywood? Yes. Is your character is woman? No. Does your character appear in Naruto? I don't know about it. Okay, don't know, right? Is your character is more than 70-year-old? Yes. Does your character holds the KBC? You may see how much close it is reaching. So we are saying yes. Is your character is less than 18-year-old? No. Is your character is Danish? No. Does your character have a Twitter account? That's true. Does your character play GTA Vice City? I don't know about it. So is your character is a rock singer? No idea. Is your character associated with the Khan, Kapoor and Bachchan clan? The answer is yes. Is your character between the age of 15 to 26? The answer is no. Is your character is between 20 to 25 years old? No. Does your character live in Wild West? Don't know. Does your character have a famous son? Okay, that's true. Yes. Has your character won the Cricket World Cup? No. See how beautifully it has find out what I am thinking. So basically this game is designed via using a decision tree concept. So it is asking input in form of character, and then by drawing the decision tree, it will help out us what character we have assumed, right? So this game is basically using the concept of decision tree.
Now these are the main takeaway points of the decision tree. Like a decision tree model basically gives the final output after checking various conditions and following the various paths. In decision tree is going to have the root node at the top, giving rise to several nodes in the next level, and finally we are going to have a leaf node. In decision tree basically we built by using the concept of entropy and Gini index. So basically entropy is the measurement of the randomness of the data. It represents the level of impurity in the data, whereas Gini index is the direct measure of impurity in the data. In decision tree, the root node is selected based on either entropy or Gini index. The node with the more information gain should be selected as a root node for the decision tree. Now in a decision tree, basically the entropy value will be in the range of 0 to 1, whereas the Gini index value lies between 0 to 0.5. Thank you.